Welcome to the Dr. Dana Show. Today we have an amazing guest, not only an amazing guest, but a mentor of mine and someone who I've respected for a long time. He is probably, in this country, the innovator and the founder of Exosomes, the finder of exosomes, or EVs as we call him, Dr. Duncan Ross, PhD. He's also the CEO and founder of Chimera Labs. So welcome, Duncan.
Well, thank you.
Thank you for coming on today.
Inviting me to this beautiful facility. It's
You got it, man. Well, we want you here.
wonderful place.
We want your brain here. The rest of you just want that brain, okay? a while ago, like a few years ago, I went to a lecture and they were talking about, what's the beginning of MSC stem cells, mesenchymal stem cells. And correct me if I'm wrong, but I believe they come from placenta, right? Pretty much.
The ones that I use come from placenta.
Okay.
However, they're present in every organ of your body.
The thing is, we can only use the placental because if not, then obviously we'll have to cut up a fetus, so we never want to do that.
Never want to do that.
We can only get them from placenta.
Well, I chose to get them. We can get them from lots of places. You can get them from the fat. You can get them from the bone marrow. You can get them from a kidney, but I'm not going to go around grabbing people's kidneys.
Sure.
But fat and bone marrow traditionally is what has been used because it's easy to aspirate and take out of a living person.
So that's what the doctor's doing in their office?
That's what they're doing in their offices.
Okay.
And when I was in graduate school working on bone marrow transplantation, so I'm thinking about hematopoietic stem cells. I'm thinking about that kind of transplantation, cellular therapies, right? I was not thinking about mesenchymal stem cells. Okay. And that research started coming along by Dr. Kaplan.
Yeah. So Arnold Kaplan was probably the grandfather of figuring out these MSC stem cells that are lining the vessels, right? They're on the vessels, they're on the vessels themselves.
That's right.
Okay. And then we found out that if we would use the placenta, obviously we can use placenta or fat, that if we had used these in the human body, they would change immensely, help health and many different kinds of pathologies and things like that, right?
And what's interesting about what he said, he first called them mesenchymal stem cells.
MSC means mesenchymal or mesenchymal stem cells.
Right. But then he changed it to medicinal signaling cells because we thought that the cell in vitro, we can convert those cells to cartilage, a bone, or fat. And the idea was that we thought that injecting those cells into the knee, they were suddenly going to become cartilage. But then we slowly started seeing that that was not what was happening. Right. But the patients were improving. So what was happening? And it was the signals. And so as you mentioned, the MSCs reside on the endothelial vein. Mm-hmm. Why do they reside there? Because, and we didn't understand, like the understanding started to come. Yeah. Oh, because they're secreting exosomes, and so they're signaling.
So they're not going to the place where they need to go necessarily because they're on the vessel. They're jumping in the vessel.
They're staying on the vessel and then sending the signals out.
Exosomes into the blood where it needs to go, and there's a beacon right in your body that's kind of homing in on these, telling you need to go there, right?
Right. So inflammation will cause those MSCs to leave where they are, go into the vein, go to the inflammation. But once they're there, then they start secreting exosomes. But it was the signaling part of it. So we've known about signaling for a long time, right? But I did the 2 coursework PhDs, biochemistry and immunology. And when I was in biochemistry expressing proteins, those proteins are very labile. They disappear in seconds, Wow. So to me, how is this going to work? You can't really send proteins through the whole body. Sure. You can send hormones. And it wasn't making sense to me until I understood what an exosome was and that it was the carrier of the signaling molecule.
So you knew there was something going into the blood that's going to repair somewhere, and you thought it was these proteins, but you couldn't
I thought it was proteins, but it couldn't be physically
possible. So you were already
possible.
on to this. You were kind of searching for this, like, holy grail of healing, maybe.
That's correct.
Oh, cool.
I could see that the signaling molecules on their own without the cells were working. Right. But what's in there? Yeah. And it's not that easy to figure out because you can't see it, right? So until the microscope that I have, the ONI microscope,
it's an electron microscope, right?
It has the same capabilities, but it's light versus electron. So the way it works is, and it's a very expensive instrument, there's only 50 of them in the United States, is that it hits this tiny virus-sized particle with a laser, and it'll only get 1 or 2 photons, right? But it'll do that thousands of times and collect those photons to regenerate an image. Wow. So you can never see it with the naked eye, but you can collect it and in a computer. That's how you could do it, right? But that didn't exist until 2014 when I was trying to figure this out. Right. We think about a planet 9 right now that you can tell through gravitation that it's there, but you can't see it. So I had to come up with 10 different ways of looking at it to believe it until the microscope actually came out.
Wow.
And that was by looking at the protein concentration, by looking at the RNA concentration, by breaking down the vesicle and everything, running it in over a gel, and then looking to see if the surface markers were in a gel. I mean, that's a lot of work. Western blot, it's 9 different kinds of things, 10 different things. And that's what we do in my lab, but that's why I have 50 employees. I have to do all of these things.
Right.
To make sure that every lot comes out with exosomes of the right
Well, I
purity.
can say that every time I've used your stuff, it worked every time. And the guys all tell me they get erections for 2 months after doing your thing. And I tried other companies, and it didn't happen.
Well, see, I haven't tried other companies, but I do know that that's why I don't do it every month, because it's too much.
I'm not saying that's that's the only thing we do, but that's a nice, easy benchmark to get the feedback,
right,
so you know it's doing something.
And where did that benchmark come from? I got that benchmark when I was using mesenchymal stem cells. And so I didn't just move to exosomes. I had to prove it to myself. So I knew that X amount, for whatever your indication was, X amount of cells would work, right? Whether it was COPD or multiple sclerosis, whatever. Right. So when I understood that exosomes could replace, I had to start treating those patients slowly by lowering the amount of cells and increasing the amount of exosomes until I was comfortable with exosomes alone getting the same efficacy. Okay. And one of those efficacies was erections, right? So I knew that 20 million MSCs would give these men erections. Yeah. And then I dosed the exosomes up to where I would get the same thing. Right. What is in the vial is directly related to what a number of cells does.
Oh yeah,
but
it just seems to work faster, and it don't get any kind of no infections can come from that.
No infections. It's impossible for it to be contaminated because it's so small, and we pass it through sterile filters. Well,
that's why
times.
The FDA likes you so much, and you have INDs, and you're going to be the first one on the market to get these out to the public, which is why he's here today.
It's really, I'm getting there. It's really starting to take
hard, though.
off.
I'm telling you, it's hard.
Yeah, it's been very, very hard. Like, for instance, I just literally 2 days ago uploaded 2 more experiments that they asked me for in May of 2023. It took me 2 years to get those experiments done.
That long?
Because the labs that do them, they're backed up, and so just to get the data done, they finished the experiments in October, and they just gave me the final report a week ago.
So everything's slow. It's like
everything's slow.
Yeah.
It's going, and I'm here in LA because it is going.
Well, it's so good to have you here. I didn't think it would ever get you to come here. I thought this was going to be a remote. I'm like, hey, why did you move to TV?
There's nothing like in person.
No, it's awesome. Yeah. So let's talk about anything you think, like what's new, innovating, or maybe why your exosomes work so well. How do you know you have the exosomes? Because I know a lot of companies don't really know what they have in the vials, right? And I think that's important.
They don't. They like to look at particles. And so as I was mentioning before, the hardware didn't exist when I figured this out. As hardware came along, I would purchase that hardware and I would try to believe it, and then I would see that it was wrong. The particle meters that came out, they're showing particles, but they're not showing exosomes.
Isn't that Brownian motion shows particles?
Yeah, Brownian motion does move these particles around. That's why they're so hard to track. But if you just shine light into liquid, you're going to see particles scatter light, right? Sure. The companies are trying to tell you, those are exosomes. And so I believed it too, until I started seeing that the number of particles were not correlating with the efficacy or the protein concentrations. Okay. And so I started to doubt it. And in fact, my staff started to doubt it too. I mean, I drove one of them crazy trying to get these to compare. Right. And then I realized this machine is lying to me, and I had to stop using it. But now the rest of the exosome field is still using it and saying, we have X amount of exosomes.
Well, do the other labs have a PhD with the 2 degrees that you have?
No, they don't.
I know.
And that's the problem. Unless you knew all of these different educations, you can't figure it out.
You don't know. I keep saying that. My practice, and sometimes it comes up, even myself, it's like, we got to always remember, we don't know. We got to keep searching.
And I think about it all the time because, it was not fun for me to switch from biochemistry to immunology and start over. I thought, how am I going to do this? But then when you look back, having those 2 educations, the value of it is much more valuable than it.
So you grew up in Miami.
Born and raised in Miami.
And
yeah.
you went to, so what was the story you were telling me before? You were in Catholic school, but you were too smart, and because
yeah.
Miami was a large Jewish population, what happened?
So I grew up on Miami Beach, and there's a very nice church there. It's called St. Patrick's, and my two older sisters went there. The older one went through. The second one, they skipped a grade. And then by the time I came along, the priest said to her, he's too smart, and they have a really good program over at the public school. They have a gifted program over there, and so all the Jewish kids were in the gifted program, and the Jewish parents were funding that program, and so we had 10 Apple II computers there. I mean, how expensive was that?
Back in the day, wow.
Back in that day, right?
Nice.
I mean, who has that kind of thing? No school had that, right?
Yeah.
They're learning Shakespeare and learning how to program at 8 years old, and
wow,
it
really?
was just amazing and that's a public school, right? So. And the temple was right across the street from the public
Well, your last
school,
name's Ross. You fit right in.
I fit right in. I mean, I have many times played both both fields there.
Played the card, both areas, yeah. Cool. I came in about 6 months before Livian blew up.
Yeah.
And so that was kind of like the beginning, right?
Livian.
They had a hard time.
They had a hard time, but they had a hard time the same way other exosome manufacturers are having a hard time right now, because they're taking birth tissues, umbilical cord, and they're vialing that, and they're just reselling that. And no matter what you do, if you make 200 vials out of an umbilical cord and you test 10 of them and those 10 are sterile, there's just no way you can tell that those other 190 don't have something in them. And without fail, there's something in them. And so if someone gets contaminated all the time, and then the FDA is called, and the FDA says, well, what did you give them? We give them exosomes. It says it right there on the vial. Now, I know there's no exosomes in that vial, but it says exosomes on the vial. And so then the FDA comes and says, we're going to shut down all exosomes. And that's how
everybody suffers.
So everybody suffers.
Well, those are MSCs, I think. Wasn't Livian with MSCs?
Livian was MSCs.
So that was...
But people are doing what Livian did, but just filtering out the cells now and selling the rest of it. And so we're still getting contaminations, and I see it all the time. When the FDA inspectors come into my lab and they see the word exosomes on the wall, they say, but you make exosomes? I said, well, damn straight, I make exosomes. That's what we do. Yeah. But we know how to do it because we're culturing the cells and we test those cells. And if the cells that we're using, I manufactured in 2018, and so it's pre-COVID, so there's no way COVID could be in there. And we've been using it over 500,000 people. That's safety right there, right?
Explain that process and explain why that process doesn't burn out. So there's some scuttlebutt about your exosomes not being very efficacious because you use the same cell line and it burns out or something like that. I mean, this is what I've heard, so I want to get it out in the open.
So when you have a placenta, there's billions of cells in there. If you're careful, as I was, you can generate many, many cell lines from that, and you don't have to keep replicating the cell. So in 2018, I replicated them a few times.
Replication is what for the public exactly?
So you take the cell, they grow, and then you split them, and then they grow again, so it's kind of a logarithmic growth. And once you get to a few passages, they're called, a few doublings, then you freeze them down. Okay. So I have not been growing the cells all this time. I froze them down in 2018, and then every time I want to make a lot, I pull one out.
And that's only a couple times they've been grown.
Just a few times.
So the other people are thinking you're just growing them out like infinitely.
Right.
Okay.
But that's not what I did. I was careful at the time. And remember, I've been doing this a long time. So 2018 was not my first placenta. I had 3 before that. So by the time I got to this one, I knew, hey, I got to do this right because I want it to last and I want it to be FDA approvable. So the FDA did ask, what I have to prove to the FDA is, if I had replicated the cell many, many times, the cytogenetic profile would not be correct. You wouldn't have 23 chromosomes. You'd have all kinds of weird things.
So if you put it in somebody, it wouldn't work? It would hurt them?
It may hurt them, right? We don't know if it would or not. Okay. But first of all, I'm not putting the cells in. Right. But what the FDA doesn't understand what an exosome is, they do understand cell therapy, right? And their requirements for cell therapy are that the cytogenetic profile of the cells be normal. And so I had to demonstrate that. So we karyotype the cells and we show it. So that's how I prove that I haven't replicated the cells too many times, because the cell profile.
Now, is that the thing that's called the danger zone or something, when those companies, some of them in Central America, are expanding the cells way out and they say we have 250 million cells, but they started at like what 10 million? Is
That's
that
right.
and that's not good.
That's what they're doing. That's the problem.
And you're talking about that's a problem you could have.
That's a problem you could have.
Okay, I got it.
And certainly, if I was, the nice thing about using cells from somebody else is that you're going to reject them anyway in hours, right? But if I took your cells out of you, replicated them, then I'm causing chromosomal aberrations, and then I'm going to put them back into you. I'm absolutely not doing that. That it's basically introducing a tumor
But when we
into
use
your
the
body.
MSC stem cells from other companies, I mean, my body would reject them.
Yeah, in 8 hours.
Is that how they work, or
No,
they only work for a little while and then they
work
die?
for a little while, secreting exosomes, and then they die. But in that time that they're in there, they did secrete some
So
exosomes.
8 hours, that's all we're getting. Huh?
That's all you're getting. When it's an IV.
Right. And what about fat? Because I know there's one company I really like. I think they're pretty legit. The adipose. Is that different?
If I take out your fat and use those cells, that's good. Because those cells are healthy. For instance, I did that in COPD. I really built my lab on COPD.
And you use the cells
and
to
I
help
used the
people like
patient's own
COVID or
cells.
whatever.
And I would almost get 100% efficacy immediately. 80% of the people their FEV1s would go from very low to high.
FEV1 is a marker of how much they're breathing.
How much you can breathe.
So COPD can't breathe very well, so that means FEV1 has a standard, and that would be normal.
Right. So I would send them home with spirometers, and I would track this. And so COPD is actually how I allowed myself to go from cells to exosomes.
Oh wow, you can tell right away.
Because I could tell, right?
Yeah, they were really sick.
When I take out their cells, I could only give them one treatment, right? They would all get better. Some of them would sneak a cigarette and then they'd come back to me. Now, I can't ethically, in good taste, ask somebody for $12,000 again, but they want it back, So I was getting very sad because you get a connection to these people, and you hate to see them go down when you had them up, right? That when I started understanding that the younger cells were working much more effectively than the older cells, and that I didn't even need the cells, I needed what the cells secreted. Yeah. Now that allows me to change the protocol to treating them, giving them very little every other day for 3 weeks. Oh, wow. And that was better than one shot of their own cells, being tracked with these spirometers. Yeah. And so I had 50 patients. I'm tracking them every 2 days. Their FEV1s are going up. That's what allowed me to release myself from cells and go to exosomes.
But these are all using, was it homologous? Or it's their own cells?
I used their own cells at first, and then I used allogeneic third-party exosomes from a baby, from a placenta. And I saw better outcomes than their own cells.
Yeah, well, that's what I've heard.
Yeah, so that's when I never looked back.
And that's what your lab's making now, right? You never look back. And you have a lot of other pathologies where you figured out whatever the FEV was for breathing, you figured it out for other organ systems, other pathologies.
Right. Yeah. So that's how we figured out the dosage, right? Right. Somebody said to me the other day, I said, well, when I told him that protocol that I figured out, that took a lot of work, right? He said, oh, well, so we're not doing enough. I said, well, what is your protocol? Well, we give them a shot once every 3 months. But well, how'd you come up with that protocol? That's all the patient could afford, right? But that's not how you figure out protocols. Well, what if they sell the patient on, say, Alzheimer's? Oh, we're going to give you all these cells. Well, those cells don't cross the blood-brain barrier. How is it going to help your Alzheimer's? I know that maybe while those cells are in there, they're secreting exosomes that may go to your brain, but that's not enough. And that's why I'm here in LA and why I'm so fortunate to have met the people that I met here. We discussed earlier how I have 2 different educations, but there's a lot more educations to have, right? Sure. And the neurologists that I met here have that education that is completely.
Can you say who you're working with?
It's Dr. Sheldon Jordan
and from UCLA, right?
From UCLA, and Dr. Taylor Kuhn, also from UCLA.
Nice.
He's a clinical psychologist, PhD. As Jordan is an MD. And really, what it is if you're putting something in somebody's brain or central nervous system, you must really trust it, right? Yeah. And that's kind of what happened with us. I wasn't so happy that people were doing intrathecal injections with my product in 2015, but we had a safety profile.
Intrathecal is what exactly?
It is right into the central nervous system.
Into the spine?
Into the spine, right. If you have any contamination there, you're in trouble, right? And so that's kind of where our fame came from, that you could trust that we always had a sterile product. But it goes even further now. It better be sterile, but it better have in it what you want.
Can we talk about those first few years where another doctor, I don't know if you want to talk about him, got people who are paraplegic. Can we talk about any of that?
We did those then. We don't do them now, but those patients did get better.
I mean, they move their legs, right? I mean,
They
these are
moved
people
their
that are
legs,
completely
some
paralyzed.
Some of them are walking.
Right. So just listen to that. This is how powerful this medicine is.
Walking, and actually what they really wanted was their bladder control back and things like that.
Yeah.
And that's what made them happy. And
So they can go to the bathroom by themselves.
Right.
You don't have to rely on somebody.
They can have,
because that's very
sex and they can go to the bathroom by themselves.
Degrading.
I mean, I don't care if I walk or not. I mean, I just want those two things. And that's what they would say.
And you can get that back for them
we could get that back from them. I mean,
how many exosomes would you use on a patient like that? I mean, we're talking like hundreds and hundreds of millions, or Ross
units.
Ross units.
Right. Well, I had to come up with the unit. And again, it was not for marketing purposes. It's for us internally to make sure that every lot is the same. Okay. Because the number of exosomes doesn't work. It's just not the right way to do it. The right way to do it is to know how much RNA you have and how many proteins you have. Because you could have a ton of exosomes and they have no RNA in them. And we've done this before. We've changed our process.
So what's the significance of that to the public? Why? Who cares about RNA?
So proteins do things, but they're there, like I said, for seconds, if not minutes. RNA does things, but it's there for a much longer period of time. And the RNA can make proteins. The RNA can control how proteins
mRNA
work.
you're talking about?
There's messenger RNA. Okay. There's also small signaling RNAs called microRNAs. Okay. And those will attach to proteins and make them act in different ways. Without those, you're not going to get any efficacy. And we have changed our processes and lost it, and so we have to make sure that we have that. So that's why we came up with the system. I mean, because if you use it once and it doesn't work, you're never going to come back to me. I've been paranoid about that since I started and wanted to make sure that it always worked.
And your facial one, the Vive, I know you have another one now, and I use that. I used a couple different people's, and I got to that, and one lady, her whole face peeled off. Her whole skin, it was like new skin came out. I was like, well, how could it peel? Well, it's powerful.
Well, it was
cool.
And ever since the first patient who burned his face off, and I saw that skin grow back, I just wasn't a fan of that system at all, and neither was Dr. Jordan. So. But what he knew was that for 20, 30 years now, we've been using low-intensity focused ultrasound to monitor brain blood flow during heart transplants. So if, while they're cutting, any large particles go in there, it may cause a stroke or something like that, or an embolism, you can see it coming through ultrasound, and you can try to do something for the patient, right? You learn this in school, but when you observe something, you're making a change to it. Light hitting something is making a change to it. So when you focus that low-intensity ultrasound on it, you are changing what you're looking at. You're looking at the vein, but you're changing it because you're hitting it. It was sort of found that you could open the blood-brain barrier. There was more blood flow wherever you focused that ultrasound.
From outside the body?
From outside the body. Think of how much experience Dr. Jordan has to have to think of through all these things, okay? He starts learning that there's more blood flow there. He starts treating patients with exosomes, and he thinks they're being targeted there because he's seeing these 10 out of 10 outcomes in depression and things like that.
So all just resolving everybody?
Everybody except dementia. Okay. So dementia was one where you could think it's not inflammation-based. Dementia is an actual loss of neurons, whereas Alzheimer's, Parkinson's, that's inflammation-based. Depression is inflammation-based. Stroke is inflammation-based. And so he saw all these great outcomes. This was years ago when that he was doing this. Now we're going to start up again when I get these INDs approved with the FDA, but we do things out of the country now, like for instance in Costa Rica. Cool. He saw blood flow there, he saw these outcomes, and he started to hypothesize that more exosomes were going where he was focusing the ultrasound, but we're not sure. It sounds like a nice idea. So Chimera funded a study at the City of Hope where we took a rat, we made a little rat transducer and gave them the same protocol that we were giving the humans before. And we put a dye on my exosomes. So I'm not just telling you there's exosomes in the vial. Now we track them to the brain, and we can see that without focused ultrasound, some exosomes do still get to the brain because they're so small. Okay. But where we focus the ultrasound, 10 to 100 times more exosomes would come.
Okay, so you're shining the light in my eye? I mean, how are you even getting it anywhere near the brain from outside the body?
Well, it's sound waves, and it's very high frequency sound waves. Okay. It's like a cone. So you put the transducer right up to the head. So you have to do an MRI of the brain first to know where everything is.
Yeah.
Then he has to calculate how much power and at what angle to put this transducer to focus the point of that cone where he wants it to go. So, but he's focusing it. And so he's developed these protocols and his systems to know where he's targeting, which is a feat in and of itself.
I mean, hypothalamus, pituitary, wherever. What if he had a pituitary tumor or something? You could get him to go there and shrink it down?
You could target glioblastoma. But then he started to read papers demonstrating that if you regenerated the neural stem cells around the hypothalamus of a rat, that rat would live 5 times longer. It's the hypothalamus controlling your growth and telling the pituitary gland to start secreting hormones. So if you just, I would have thought I had to get my exosomes into your entire body.
You did that, right?
I've been doing that for 10 years. But by him figuring out that we could get the exosomes to the hypothalamus and make the hypothalamus think it's younger, now it will take care of the rest of the body. And that's such a leap. I have done it now. After we did that experiment in the rat, we published it in Nature Scientific Reports, one of the best publications I've done since graduate school. And then I said, okay, I want this done to me. In the paper, the mouse paper, the rat started to be able to run a maze and have better spatial acuity 4, 5, 6 months after treating the hypothalamus, meaning the exosomes are long gone. Okay, so you must have regenerated that hypothalamus to see these changes months later. It started happening to me. I started noticing I had actually fallen off my dock the year before. I would slip when I would jump onto my boat in the socks because my weight wasn't properly distributed. And I started noticing that I could jump up and down off the boat without slipping. I was like, oh, this is pretty cool. I wonder if this has anything to do with the treatment.
Yeah.
Then time goes on, and I saw a saddle horse, and I thought to myself, I can jump over that. And I'm turning 50 this year. I don't jump anymore, right? And so I went and I leapt over it, and I landed like a ballerina on the other side. I can't believe I did that. And then another guy saw me do that and tried to do it, and he hit it and fell. So I was like, what is happening to me? So I grew up as a professional tennis player. I haven't played in 20 years because I lost control of the ball, timing. And so when I hit it, it goes and hits the back wind stop. It doesn't go right over the net.
Right.
And so in January, I had gone to hit with people who were really good. One played Wimbledon, and I hit with them for 3 minutes and I quit because it was too embarrassing. I said, forget it, guys. I'm not playing with you. And I kind of resigned myself that I was never going to play tennis again.
Right. That's before you had the treatment.
That's before I had the treatment.
Okay.
So now after I jumped over that saddle horse, I should go try to play tennis.
Yeah.
And so there was a clinic on the roof of the hotel I was staying in. I went up there. I said, can I join you? Forlorn with my racket and my towel. And they said, we're full, you can't join. Oh, sorry. Will you just sit with me for a second because I want to test this? Yeah. And it was 15 minutes before the class. So I started rallying with the girl, and she goes, you know what? You're really good. I think you should stay.
Why? They saw that you were older, and at first they didn't want you, so they said
didn't
they're
want
full?
me, exactly. So he goes, I think you should stay.
That's really
and so they let me stay, and for an hour and a half, I'm hitting between my legs, and I'm basically having another pro on the court.
Like back to where you were in your 20s?
Back to where I was in my 20s.
Without even having played?
Without having played in 20 years.
You discovered such amazing things.
This is impossible, right?
It's like you become Spider-Man.
So when I was done, I even tried to pay her for the clinic, and she wouldn't take the money. She said, no, you're welcome anytime you want. So cool. You're my friend now. I was like,
yeah, because you make them look good and you come teach classes.
And so then, that was here in LA. I went back to Miami. I hurt my foot. I couldn't play.
Right.
And so I was like, this is how I'm going to get myself back into shape. Tennis, that's what I love. I don't like the gym, etc. Yeah. So I just went to go play 5 days ago before I came here. And guess what? It happened again. I played the whole, I was so calm.
So it's still working?
It's still working. And I haven't hit since then. But I walk up to that ball and I slam the backhand and it goes right over the net. And I used to be scared to hit that. And my
fear, yeah, I played for a while. Right. It's like, is it going to work?
My backhand in high school was awful.
Yeah.
I would miss, 2 out of 5 times. Okay. Now I just walk up to it and it's 5 out of 5 times. And I don't know what's happening. It's this acuity, it's the calmness, and people call it flow state. I didn't think I knew what that word meant before.
It's like Caddyshack, like be the ball.
It's like Caddyshack, be the ball. That's where these players are getting. That's why players have their little ticks that they do, because they want to stay in that focus. But now it's just naturally, everybody has reported this that's done it, that they have this calmness, that their metabolism increases, that they have better spatial awareness.
So what's the cost of this? Like 100,000?
What a great time. No, I think it's more like 25,000, but
Wow.
they're charging that in Costa Rica, I believe.
So we're not doing the States right now.
We're not. Well, I'm trying to get it approved. I'm putting in. That's why I was waiting for those 2 experiments.
Nice.
So I would have tried to get it approved last year, but I have to test them for everything before we get started.
Yeah.
And then what is the frequency I'm going to test them after we're going, and what's the dose? So
If I can be any part of this, please let me know. I would love
but
to do it.
it's fun. I mean, it's exciting, right?
No, it's totally exciting. I mean, think about that. How many people would want to be able to go play, whatever the sport was, and hopefully not play football, and get concussions and, TBIs, but or even scientists or people that think they're done in life. They can come back and be emeritus professors. I mean, my dad. Oh my goodness, my dad would need this because he's starting to lose his memory a little bit.
And that will extend as we get these approvals. It will extend to Parkinson's and Alzheimer's.
Okay.
And Dr. Jordan has had patients with stroke that were completely incapacitated come back to speaking completely normally and being able to cook. It's just fantastic what's coming.
Anything else for the future? Anything you want to talk about today?
There is one other thing. Your expertise, I told you I have a patient for you who is complaining that, he's sensitive to everything. He goes out in the environment and anything will trigger an allergic response to him. I'm a PhD. I do not know how to diagnose people or figure out a treatment regimen. But I do know this. We've had a number of patients, and what I've had learned is that if you have, say, TGF-beta-3, it's a protein, anti-inflammatory protein. It'll turn an inflammatory CD4 T cell into a regulatory CD4 T cell. Just that protein alone. That's what's causing arthritis, is these inflammatory cells. Theoretically, if you bathed the human, like when we're a baby, we're secreting lots of anti-inflammatory cytokines. That's how we tolerize ourselves to ourselves and don't attack ourselves. So what if we gave enough, and this was my theory, to stop an allergy? So I had one of the docs that I used to work with, and I would go to lunch with him, and he wasn't able to order anything. I said, "What's going on? I've had lunch with you 100 times. Why don't you order anything?" He said, "Well," he said, "if I have any gluten or shellfish, I'll be on my couch for the rest of the day. I won't be able to work because I'll be in so much pain." And I said, "Look, I'll make you a bet. I'm going to give you a 5 ml plus, and you're going to take it right before you go eat, and I'm going to tolerize you to this antigen."
Right.
Well, he didn't listen to me. He did it before and after, because I gave him another one just in case. But it cured his allergies for 8-9 months, and he was fine. And so I was like, okay, that's great. But he didn't have a lethal allergy. So then we have another practitioner
For
now.
anaphylaxis?
They call it anaphylaxis,
okay,
right.
yeah.
Would go within 15 seconds of experiencing dairy,
IgE?
would go into an IG response. Yeah. And she had used her EpiPen 6 times in the last 6 months. Her husband always had to have his phone on him in case he was upstairs. She contacted something, because when you even have compounded medicines, they might be compounded with lactose, and she never knows, right? I said, well, listen, you're not going to do this around me because it makes me nervous, but I believe that if I give you a large enough dose, and she's about 120 pounds, I gave her 3 times the dose of a full-grown man. And I said, if you take this prior, I think I can tolerize you to that antigen at once. And she did it, and now we're out 15 days, and she's had no response to dairy. And every day now she's taking small bits of dairy, because that's the Jewish tolerizing protocol, which is the problem, is that the AMA said don't let your child experience peanut,
So a couple other things we want to discuss today. So tell us about this the snake-like looking thing you put on your head for sleep.
It's just amazing where our species is going, that these kind of things exist. So this is a company called Irritable Neuro.
Irritable?
Irritable. Irritable, because you put it over your ears, and it has bone conduction technology, but it also has these sensors here. And so it can read your alpha and beta waves, and it can tell you whether you are in a stressful state, whether you're a relaxed state, whether you're in a flow state, and it will try to give you frequencies to get you, say, if you want to go to sleep, or if it wants to get you into concentration mode, into concentration. And so what I'm doing with Dr. Jordan, and if I'm telling you that everybody mentions being calmer after the therapies and everything like that, I need to track that with data. Okay. And so this is how I'm going to do it. And it was just amazing. You just put it on like this. It's battery operated, you know, it says USB-C. You can sleep with it. And I can now test the patient before we do the therapy, and now test them afterwards, and be able to see over time them their concentration increasing, their calmness increasing. Right. So that was all these things revolve around Dr. Jordan and his neuro associates and what they've been able to do for the brain, because the body's great and everything, but we want to be cognizant. I mean, it's what's up here. So. Definitely. One of the reasons we're such good friends is that many years ago, you know, he's 72 years old and he drives a Harley.
Now?
No,
now?
Before,
okay.
Now he drives a scooter, but he was driving down the street and it had rained, and it's always because it had rained. And a woman comes out in front of him and he doesn't have time to stop. He moves the bike slides out, and he crashes and he breaks 15 ribs and his ankle.
Collarbone, wasn't it?
Collarbone as well, I believe, yeah. You know, I was so excited about what he was doing. The very next day, I sent him 10 of our most powerful product. He used 5 of them immediately, and then he used 5 3 weeks later. But 4 weeks later, he had no more rib pain, and his ankle had healed. Now, that sounds crazy even to me. You know, I know the power of my exosomes. I love them and everything, but that's a lot.
4 weeks? Yeah, well, he was supposedly shopping for food, and within 2 or 3 weeks.
2 or 3 weeks, but he did something else that needs to be spoken about, and that's why a practitioner must treat you. You can't just use my exosome. Right. He was using red light therapy after the exosomes, so red laser therapy. So you put the exosomes in, they do go where they need to go, where inflammation is, but when you hit them with that high intensity red light, then you increase the mitochondrial function, and then the cells operate more
so
rapidly.
So if I did that in my clinic, I should put the red light over them after they do it?
That's correct.
How long do you use it for? Like a while?
Well, 15, 20 minutes, you know. But just, it's the timing of it. Get them on there and then get the red light afterwards. Right. So it's, again, it's great. We have all these different modalities, but you have to know how to use them, right? And peptides are another thing that I'm not versed in, you know, but if combining those with my exosomes at different protocols, yeah.
We do some already, but it depends on the patient, what they can do. This is so cool. Well, I've spoken about things that are miracle. I mean, sounds like miracle, but it's science, and it's amazing science. And because you have those 2 degrees, and you went to the Jewish school at 8 years old, and you learn how to program. Then we have this, you know, epiphany. Yeah. This guy here, and knows all this stuff. And then
we have all these things these days, like this Aura ring showing me my deep sleep.
That's an Aura ring, cool.
Yeah,
actually, they work good.
Actually, Dr. Jordan, he knows when to treat himself based on how much deep sleep he's getting. So as we get older, you know, you end up at 15 minutes of deep sleep. That's not enough for your cells to regenerate. But when you treat yourself right, you know, you can get that up. I've had 2 hours and 30 minutes of deep sleep before, recently.
In one night?
In one night.
Wow.
Normally it's 1 hour and 30 minutes. It's just being able to track it, and this can track that too.
Because I have the Garmin watch. This was a few years ago, and it measured every little thing. But the sleep, I could see it. I never realized the significance of, I know you're supposed to be in REM sleep, but what does it actually mean? So you're saying that if you don't get enough REM sleep, you won't regenerate stem cells?
Enough deep sleep.
You
need to get enough REM and deep sleep. But that's actually why younger generations are drinking less, because they have access to these things that we didn't have, and they're checking it out. And they're even using glucose monitors when they don't have diabetes. So just because they can. And by monitoring it, it makes them think, hey, I should probably be healthier because I'm not getting the deep sleep. And so that's why all these trends are happening.
I didn't know that.
Yeah, in younger generations.
Because most of my patients are 45, 50.
Well, we just, you know, we drink every night and think it was fine. You know? But
well, listen, it's great to have you here. I'm sure you got a million things to do today.
I appreciate seeing you. Thanks.
Pleasure having you, Dr. Ross. Thank you so much. Thanks.